Thanks everybody for joining. In this talk, I'm gonna be talking about DevSecOps and shifting left smart contract development. But first, a little bit about myself. Who am I? I'm Joran Honig. I'm a security researcher and product lead at Consensus Diligence. And you might know me from a few open source projects, which I've listed here, MYTHX for Solidity, amongst others, which are different projects for automatically analyzing and maybe finding bugs in Solidity smart contracts. I set up this link to a gist with all the links that I'm going to talk about throughout the presentation so that it's easy to navigate to it. Okay. So shift left. What does it mean to shift left, and what are we actually shifting left? So shift left generally talks about this generic concept of testing. But in this talk, I want to specifically go into the security aspect of shifting left. Shifting left also means that there's something to shift left from, that there's a right position. So what does it mean to be right? Are you right? So this graph tries to show the traditional model, or the model where testing or security is shift left, right. On the horizontal axis, you see the various stages of the software development lifecycle. And then on the vertical axis, you see how much testing is applied in each phase. You see in this traditional model, all the security is put towards the end of the process instead of at the beginning or all throughout. So security here is really the final step. What this might look like normally in development of smart contracts is that you do an audit right before you launch. And there's going to be two major goals there. The first one is to identify and mitigate any security risk. You don't want any flaws in your smart contracts. The second is that your audit report signals to users that you've done your due diligence, but also what the potential remaining risks are. So what's wrong with that? What's wrong with doing an audit at the end of your development lifecycle? And I think there's nothing wrong with that. Please don't stop doing audits towards the end, because there's a lot of merit to them. But I'm going to give a few arguments and examples as to why you might want to put more effort or time into security towards the earlier phases of software development or smart contract development. The first one, which is that you shouldn't be wasting your time. One thing that can happen is that you find a fundamental flaw or problem in your architecture or smart contracts towards the later stages of development. That kind of sucks because you might have to redo or delete a lot of work. And that wasted work is just not a lot of fun, and it's a waste of resources. The second thing is security debt. Security debt is really just a particular flavor of technical debt. And on this slide, I've listed a few examples of how your security debt might come. The first and most obvious one is just plain bugs. Over time, without a security review, you're likely to start accumulating bugs, which you'll have to fix at the end at an audit. There's also a potential that there are accumulating areas of complexity. So over time, you add little bits of complexity to the smart contract system, and the composite of all these areas might result in complex and unintended behavior that an attacker might be able to exploit. There can also be changing risk assumptions. As a result, you might have to introduce additional controls and mitigations, which is also something you need to handle. And it's important to pay your security debt on time, because otherwise it starts to accumulate and compound until at some point you're this guy, and you don't want to be this guy. Then there's this research that IBM did a while ago on the relative cost of fixing defects. So what they did is they took a baseline cost for fixing a defect or bug in the design phase of software development. Then they looked throughout the various later stages and saw how much more it cost in time and effort to fix that bug. And maybe not surprisingly, they found that the further along in the software development lifecycle you get, the more complex the code base gets, the more controls there are put in place, the more expensive it's going to be to fix a defect. So their fixing bugs earlier on is just plain cheaper. And finally, one of the biggest arguments, in my opinion, is the following thing. If you only have security towards the end of the process, then you might come in a situation where an audit, for example, results in a critical finding or a flaw in the architecture of a system. Mitigating such findings or such problems can take a lot of time and maybe longer than there is in the planned time frame for launch. This means that you'll have to delay launch, and that's something that a product owner really doesn't want to hear. So what do? You shift left. You do security from day one instead of mostly at the end. This graph kind of tries to show you how the shift left model looks like compared to the traditional or the shift right model. And I think it's actually not correct. I think security shouldn't be lopsided towards the left, but more integrated. So you're still shifting left, but it's more equally divided among the various stages of the software development lifecycle. So what does that look like? What does it look like to be shift left? In the following slides, I'm going to go through some of the various stages of smart contract development or the software development lifecycle, and I've split it up into early, mid, and final stage. For each stage, I'm going to look at some of the automated and human processes and controls that you can put in place to improve your security posture. All right, the early stage. At this point, you have an idea. Probably you have some design documents and requirements, and it's already important to evaluate the security aspects of that design and your architecture. The early stage is also the point where you want to establish some secure development practices. Let's first go into the design review. Now, there are a lot of standards and ways to go about formulating a design document and determining requirements. So I won't go into depth there. But I think there's a few points that are important to be careful of or to look at from a security perspective that can really pay off. So the first one is that you need to identify potential risks of a system. You need to know which actors are threat actors and which are like the people or the groups of people that might attack a system. And you need to know where value is going to be stored in a system so that you can be careful about implementing those parts and make sure that they are secure. Then another topic which is super interesting and relevant for smart is the placement of trust. You might implement a system that is custodial, or you might distribute trust to various actors using some kind of secret sharing scheme, or maybe you're using a multi-sig. Then there's also the possibility of looking into some kind of governance model where you put the control over your system in the hands of the community. There's risks associated with each of these approaches, and knowing them upfront allows you to evaluate whether you want to accept those risks. Finally, and this is going to be a little bit more technical, it's important to already look at the different parts of your architecture and where you think that there's going to be the most complexity. Doing this will allow you to be extra careful when implementing those parts and introducing the necessary testing and quality control. Okay, then on the secure development processes, this is where DevSecOps comes into play. And I think, well, most of you might already do this, but you should definitely be using CI. We're at TruffleCon right now, so Truffle teams might be a very good option for you, but any CI will do really here. In CI, you're definitely going to be running your unit tests. These will allow you to regress test new features and make sure that nothing weird gets added, or at least given a control that nothing weird gets added. Then the next best thing you can do is add some security analysis into CI. Adding security analysis here that runs on every PR or every commit allows you to get direct security feedback instead of having to wait until the end of your development when you have the audit. This way you can integrate that feedback immediately and benefit from it and pay that security debt upfront. You can also catch security problems early to introduce fixes and make sure that bugs don't even hit the main branch. One of the tools that you can use for this is MYTHX, which is an automated security analysis tool that me and my team have been working on, which you can use you can submit your code to this platform, and we'll use various techniques to find bugs in it and report them on your PR. You can even aggregate your smart contracts into projects to track quality over time and use the GitHub badge or a badge to signal whether your latest scan has passed successfully, so that there are no weaknesses found by the automated analysis. So like I said, MYTHX, it's a security tool which does automatic vulnerability detection, and we use multiple different techniques to provide the best coverage possible. We use fuzzing, symbolic execution, and static analysis, and those each work just a little bit differently, and using all three of them and combining their results allows us to give the most precise and complete results possible. Finally, using a tool like MYTHX, you can even generate proof of concept exploits. Here's an example of the batch overflow bug in the BEC token contract, which was found a while back. And you see how MYTHX was able to find the vulnerability, but also report a transaction trace, namely concrete transactions that trigger the vulnerability. This can be super helpful because you can easily triage and replicate a vulnerability. So once you're out of the early stage, your code base starts to grow, and it's time to revisit some of the risk assumptions you made. Are they still valid? This is also the time to step up the quality of the code base, and it can even be valuable to do a manual security review here, a spot check. So let's talk about that spot check first. Consensus Diligence provides such a service, and during a spot check, which takes about a day, a security auditor or security reviewer will have a look at your code and inspect the architecture or the architectural design and look at various risks that are part of your system. They will also provide recommendations on these two aspects and make sure that you're on the right track. Then it's also time to think about upgrading the DevSecOps processes. The first thing you can do is start to use multiple security tools. The second is to start using code quality tools and metrics to improve the quality of your code base. So first, using multiple security tools. Why would you do this? Isn't one enough? Well, you got to understand that each tool uses a different technique or method of finding vulnerabilities, and usually different tools also have different detectors. Using multiple tools will make sure that you have your bases covered and that a weakness that could automatically be detected doesn't slip through the cracks and only ends up being reported at the final audit. Another thing you can do is start to analyze non-Solidity code. While Solidity code is likely to be like the most critical part of the code base, where a vulnerability is going to be disastrous, it's also possible to have vulnerabilities on your front-end code, or maybe you have some back-end service running. This is super easy nowadays that automatic vulnerability scanning for languages like JavaScript is integrated in platforms like GitHub and GitLab. So definitely enable those checks because it's really low-hanging fruit there. You can also start to integrate some code quality tools now. The most straightforward one is definitely Solidity coverage, which a lot of people already use. So basically, you're going to evaluate which lines of your test of your smart contracts are covered by test, which aren't. You get a code coverage out of that, and you can work to improve that coverage to maybe hit 100%. Unfortunately, code coverage is imperfect. You only really know what is being covered, not how well it's being covered. So this is where you can use a tool like Vertigo, which implements mutation testing to find how good your test suite is at finding bugs. You can also find places where it's not good at finding bugs and then improve your test suite to make sure that it will detect the bugs that are inserted by the mutation testing tool Vertigo. Finally, you can also use the tool, you can use code quality metrics as provided by the library Solidity metric to set a baseline on the quality of your code and start improving it. The concrete number might not be super precise, but having that baseline is very useful to be able to start improving on the various aspects that are being measured. Okay, then the last thing I called out is property-based testing. And this is really to go the next level on your security. You'll first determine properties that describe general statements that must hold over your code. So this is a little bit different from what a unit test does, which describes a single scenario of correctness that must hold over your code. So the properties are way more generic. Then you use a tool like MYTHX, which uses symbolic execution and fuzzing to explore the different behaviors of a smart contract to see whether the properties are valid, whether they aren't violated at any place, so that you get a warning if they are. This allows you to do in-depth, expensive testing of your smart contracts. Okay, so you have super nice DevSecOps processes set up, you've reviewed your code and set up property-based testing. Now we get to the final stage. And it's important to note that the final stage hasn't changed that much since the traditional model or the shift right model, let's say. At this point, you're going to clean up and finalize a code base and make sure to mitigate any remaining weaknesses. What are the actions here? Well, first, you're going to prepare for an audit. There's a really good blog post on the Consensus Diligence blog about this, but in general, there are 5 steps here. The first one is you're going to make sure that there's adequate and complete documentation for your project. The code should be clean, test coverage should be there, and it should be high. And you want to make sure that you mitigated any findings that the automatic security tools were able to find. You're also gonna freeze the code base at this point because it's not the moment to be adding new features. After preparing for an audit, it's time to get your smart contracts audited. Auditors will look through your smart contracts, do threat modeling, look at the weaknesses, and provide recommendations as to how you can improve the security of your code base. After the audit, you'll implement mitigations for the findings and maybe implement the recommendations that the auditors had. And then finally, it's time to launch. So what's different now that we've shift left? Well, the code quality is bound to be high, and you've already paid a lot of your security debt. Many risks will be managed, so auditors are going to be able to work more efficiently and provide better guarantees. More importantly, after the audit, there will be less mitigation time because you've already done everything up front, which is really nice because now you'll be able to release your project on schedule. Okay. Thank you for your time. I mentioned the tool MYTHX in one of the slides before. If you want to try it out, you can use this promo code to get a free month of analysis for free. You can reach me on Twitter. And if you're interested in any of the manual code review or audits, then please go to consensus.net/diligence.